I want to pause a moment and remind us all about why are we doing this? Derivatives are extremely useful for finding the maxima and the minima of functions. If we want to find the maximum profit, the minimum cost, okay? That's that's we find that with derivatives, okay? Now, I know if we can graph it, we can just pick the point on the graph, but to do it by hand, to do it with math, that's what's really happening is finding the derivatives. All right? And so that's why we're here to look at derivatives. So if f prime is the slope of f at any point, right? That's what f prime of x means. The slope of f at x. That's a new function. F prime of x is a function. It's a rule. It's a description. It's a way to find out the slope of our original function anywhere, which is pretty powerful because at maxima, the slope is 0. At minima, the slope is 0. So a lot of times we can just find out when is the derivative equal to 0, and we'll be able to find our max profit or our minimum cost. So let's look at this example. Suppose that we wanted to find the biggest value of the function on the interval from -2 to +2. What's the biggest this function ever gets on this interval? We can use Desmos to give us an approximation. It looks like it's around here, close to -1.5. But what if we needed more precision? Well, pretty soon we're going to figure out how to find f prime of x, how to find the slope at any point. But for now, just trust me that the slope of this red function at any point, right, this is the red function, the slope of this red function at any point is given by this blue function. Don't believe me? Let's look at some stuff. Hold on, let's make sure I'm not getting ahead of myself, right? What is f prime of 0? Well, just plug in 0 into f prime. 0 squared minus 2, it's -2. Do you think the slope of this red function at 0 is about -2? Whoa, it is, right? We go down 2, right 1, the slope is -2 right there. Well, let's pick another point. All right, what's f prime at +2? Well, 2 squared is 4, 4 minus 2, you get +2. Do you think the slope right here is about +2? Whoa, it is. Up 2, right 1. This blue function tells us the slope of the red function at any point. Very powerful. Okay? So, what do we know about the slope of the tangent line at that maximum? What do we know about the slope of the tangent line right here? Well, it's 0. Right? We have a flat tangent line right there. So, use f prime to find this exact location. Because we know the slope should be 0, right here at this green dot, when is the slope equal to 0? We've done questions like this before. We can find this out because we know that f prime of x is x squared minus 2. Right? F prime of x is the exact same thing as x squared minus 2. So we can just replace it. These two things are identical. Now we just solve this equation normally. We could use the quadratic formula, or we could use the square root principle, whatever you want to call it. Let's add 2 to both sides. We'll get when x squared equals +2. Take the square root of both sides. And remember, whenever you take the square root of both sides, you do need a plus or minus. There's two answers that work here. Because when you square a negative number, it becomes positive. So we have two possible places where the slope is 0. at the square root of 2, which is going to be an x coordinate here, and at negative square root of 2, which is right here. So if we wanted to find the exact location of this green dot, we just did it. Maximum is when x equals negative square root of 2. And yeah, it turns out that's about negative 1.4. Wait, I forgot. I used to know my square root's better. Where's my Desmos? Found it. 1.4142, blah, blah, blah. Yeah, pretty close to negative 1.5. So that's one way that we can use derivatives and think about derivatives as functions to find maxima and minima. We'll talk more about that later on in this chapter. Okay? But the really cool thing is that if we have a function in red, its derivative in blue tells us the slope of that function at any point, which is very, very powerful. Next, we'll talk more about this relationship and get some weird visualizations and get some more practice finding visually tangent line slopes. Enjoy. Bye-bye.